Good morning, students. In the previous period, we have completed the points from the chapter gravitation. Today, we will see some problems on gravitation. The first problem is of this type. We write that problem on the board. The problem is like this: find the mass of sun from the following data. From the following data. Here, the radius of Earth orbit, radius of Earth's orbit is given, and it is r equals to 1.5 into 10 raised to 8 kilometer, and the value of g is also given. That value is 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. From this data, we have to find the mass of the sun. Here, as we have seen the formula for the gravitation, and it is given equals to, it is given by the g mm upon r square. Here in this problem, the earth revolves around the sun in more or less in a circular orbit. The radius of the orbit, the gravitational force of attraction between the sun and earth of mass m is balanced by the centripetal force. That is, the centripetal is balanced by the centripetal force, and it is given by centripetal force is equals to m r omega square. Here in this formula, this omega is the angular velocity of the earth. Now this angular velocity of earth can be calculated, or is given by 2 pi upon 365 into 24 into, as earth takes the 365 days to revolve around the sun. Therefore, we have taken this type of formula. Now, from this we will calculate the value of omega, that is 2 pi into the value of this pi is 3.14 upon 365 into 24 into 3600, and if we multiply these quantities and calculate it, we will get the value, that is 1.99 into 10 raised to minus 7 radian per second square. Radian per second. This is the value of angular velocity of the earth. Now, the radius of orbit of earth is also given, and that value of r is equals to, that is 1.5 into 10 raised to 8 kilometer. Here we will convert this kilometer into the meter, and this can be done 1.5 into 10 raised to 11 meter. Now we know that this force is balanced by the gravitational. It is balanced with the formula as given here, right here, that is like this. The GMM upon r square. This is the gravitational force and this gravitational force is balanced by the centripetal force. Therefore, we can write here this is the centripetal force and that is equals to m r omega square. Here, this small m and this small m will get cancelled and we can rearrange this formula or this equation like this. Here, z m upon r square into equals to r omega square. Now we want to find the mass of the sun. Therefore, this capital M is the mass of the sun. As we have considered it, the capital M is the mass of the sun and small m is the mass of the earth. Therefore, we rearrange this formula for mass of the sun, that is m equals to this r into r, it is r cube omega square upon z. Now putting the values of r, omega and z in this equation and solve it, will get the mass of the sun. Therefore, I write that here mass equals to the value of r, that is the radius of Earth's orbit, and that is this. That is equals to 1.5 into 10 raised to 11 meter. 10 raised to 11 meter. It's a cube into the value of omega. That value is this. That is 1.99 into 10 raised to minus 7. 10 raised to minus 7. It's a square. Lastly, we'll write the units. Now the value of g. The value of z is also given and the value of g is 6.67 into 10 raised to minus 11 Newton meter square kilogram. Now we'll solve this. It will be 1.5 into or 1.5 into 1.5 into 1.5 into 10 raised to 33 and 1.99 into 1.99 into 10 raised to minus 40 upon 6.67 into 10 raised to 11. And if we simplify this, then lastly we will get the mass of the earth, mass of the sun is equals to mass equals to 2.004 into kilogram. In this way, we have calculated the mass of the sun. Now we will see second problem. That second problem is like this. Just write the second problem. The second problem is if the mass of the sun, if the mass of the sun is 2 into 10 raised to 30 kilogram, distance of the earth from the sun is 1.5 into 10 raised to 11 meter and period of revolution period of revolution of the former around the latter around the latter is 365.3 days. 365.3 days. Find the value of Z. Find the value of Z. In the first problem, we already found the value of capital M, that is the mass of the sun. Here just we are rearranging the values of the mass of the sun, distance, and we are calculating the value of capital G. Now here the force of attraction between the sun of the mass M and the earth mass sun of the mass capital M and earth of mass small m separated by distance r is given by F equals to Z m upon r square. This is the law of gravitation. With this formula, we find the value of this is the force between this value of force. Now, this force is balanced by the centrifugal force. This force is balanced by the centrifugal force that is given by. Therefore, we can write F is equals to centrifugal force. That is Z m upon r square equals to, and the centrifugal force is given by r m r omega square. This m and the m will get cancelled, and we rearrange this equation for Z. In previous problem, we have rearranged this formula for the value of capital M. Here we are rearranging this for value of Z. Here therefore, this can be written as r cube into omega square upon capital M. Now putting the value of all this r, omega and m and solving it or simplify it, we will get the value of capital Z. Now we put the value and simplify it. Here Z equals to the value of R is similarly. Here, first of all, we have to calculate the value of omega. And for calculating the value of omega, here we write omega is equals to 2 pi upon, here in the previous equation problem, we have written 365 days. But here the time required to complete one revolution is 365.3 days. Into 24 into 3600, and if we solve this, it will come 1.991 into 10 raised to minus 7 radian per second. This is the value of omega. Now putting these values in the value of G. Therefore, the value of R is 1.5 into 10 raised to 11 x cube into 1.991 into 10 raised to minus 7 its square upon the value of G, value of M, mass of the sun. And the mass of the sun is given, and it is 2 into 10 raised to 30 kilogram. Now, if we solve this, multiply and solve the, if we take the cube of 1.5 and square of 1.991 and or we write this one here, one step like this, 1.5 into 1.5 into 1.5 into 10 raised to 11 into 3, it is 33 into 1.991 into 1.991 into 10 raised to minus 14 upon 2 into 10 raised to 33. And lastly, the value of G is like this. If we calculate it, we get 6.88 into 10 raised to 11 Newton meter square per kilogram square. In this way, we have calculated the value of G. Now, I think with the help of these two problems, we can solve some other problems also that we'll see in the next page.